So today's learning goal is we want to be able to determine the equation of parallel and perpendicular lines. This is something similar to that we've done in the past, but we're just going to kind of be adding a twist to it, applying it in various situations. So we're going to need to kind of know multiple steps in order to achieve success by finding the equations. So we should be able to, at the end of the lesson, identify the relationship between slope and parallel and perpendicular lines, which we've actually seen in the past. Determine the equation of lines that are parallel or perpendicular. Again, we've sort of seen this in the past as well. Define a right bisector will be a new, something new. Determine the equation of a right bisector. That will be brand new as well. So going back to parallel lines, whenever I hear the word parallel and perpendicular, I should be getting kind of alarm bells in my head going off about slope. And so the key thing here is that if two lines are parallel, then their slopes are equal. Right? And so we would write that, we say, since line 1 is parallel to line 2, therefore slope 1 equals slope 2. And that's sort of the mathematical way of saying that. In the same way, perpendicular, that's related to slopes as well. If two lines are perpendicular, then their slopes are negative reciprocals of each other. So since line 1 is perpendicular to line 2, we can therefore say that slope M1 is equal to the negative of 1 over slope 2. That's the negative reciprocal. Okay, so that's all we sort of need to know. But we're going to start applying these in sort of some unique situations. So determine which of the following lines are parallel and which are perpendicular to each other. So again, I see that word parallel and I see perpendicular, so I should be thinking slope. So I'm going to need to calculate the slopes of lines 1, 2, and 3. So one possibility here would be to rearrange. These look like they're almost in standard form. Line 1 isn't quite in standard form because it's got a negative in front. But we're going to rearrange these equations into the slope Y intercept form. So we'll just say rewrite in slope Y intercept form. All right, because if I do that, then it'll be very easy to see what the slopes are. So I'm simply going to add 24 to both sides. And then add 3x to both sides. And then divide both sides by 4 to isolate y. 24 divided by 4 is 6. So from here, I know that slope of line 1 is 3/4. I'll do the same thing with the second slope. 3x minus 4y. I'll subtract 10 from both sides. And now I want to subtract 3x. Whoops, that's minus 4y. So I'll subtract 3x from both sides. Minus 4y is equal to negative 3x. Subtract 10. And now I'll divide both sides through by negative 4. That gives me negative 3 over negative 4 is positive 3 over 4. X. Negative 10 divided by negative 4 is positive 10 over 4. And I should always reduce my fractions. That gives me y equals 3/4 x. 10 over 4 reduces to 5 over 2. So this is now in slope y intercept form, which makes it easy to read what the slope is for equation 2. The slope is 3/4. And then finally, calculate rearrange line 3. I get 4x plus 3y minus 16. I'll add 16 to both sides. And to isolate y, I'll subtract 4x from both sides, giving me 3y equals negative 4x plus 16. And now I'll divide both sides by 3, telling me that y is negative 4 over 3x plus 16 over 3. Again, it makes it easy to see what the slope is for this equation. line 3 has a slope of negative 4 over 3. So these are my three slopes. And I'm asked to find out which lines are parallel and which are perpendicular. So I can say, looks like M1 and M2 have the same slope. So I can say since M1 equals M2, therefore line 1 is perpendicular to line 2. So it's parallel to line 2. They're equal. Line 1 is parallel to line 2. And if I compare slope 1 and slope 3, we see that they're negative reciprocals. So I can say since M1 is equal to the negative reciprocal of M3, therefore line 1 is perpendicular to line 3. And comparing slopes 2 and 3, I can say since slope 2 is the negative reciprocal of slope 3, therefore line 2 must be perpendicular to line 3. Okay, let's go on to our next page, example 2. The question says, find the equation of the line that is parallel to line 1, so parallel, I'm thinking slope, parallel to line 1, x plus 4y minus 2 equals 0, and passes through the point a, 7 minus 4. Express the equation in standard form. So remember, if I want my equation, I require two things to get an equation of a line. I need a slope, and I need a point. Well, my point, it passes through this point, so my point is easy. My point is just 7 minus 4. But I do require a slope. And we're not told the slope explicitly, but we're told that it's parallel to line 1. Well, since lines that are parallel have the same slope, if I can calculate the slope of line 1, that will also be the slope of this equation because it's parallel to it. So I know that the line 1 that's provided is going to be parallel to the line that I'm looking for. Line 1 is parallel to line 2. So since line 1 is parallel to line 2, therefore slope of 1 be equal to slope of 2. So this equation here, that's going to be equation 2, line 2. So if I rearrange my equation, I've got x plus 4y minus 2 equals 0. If I put that into slope y intercept form, add 2 to both sides, and then subtract x from both sides, and divide both sides by 4. Two over 4 is going to become 1/2. 2 divided by 4 is 1/2. So that tells me that the slope of line 1, I've just rearranged the equation, slope of line 1 is minus 1 over 4. And because slope 1 is equal to slope 2, I can therefore say that the slope of the line I'm looking for is minus 1 over 4. So now it's just like what we did yesterday. I've got a point and I've got a slope. I can come up with my equation using the slope point form. So the general equation is y minus y1 equals m times x minus x1. I substitute in my y value, which is minus 4. Y subtract minus 4 is equal to my slope, which is minus 1/4, times x subtract x1 is my x point. That's the value 7. When I solve this, y subtract negative 4 is the same as y plus 4 is equal to negative 1/4 x. Negative 1/4 distributed to the minus 7. Negative times a negative is a positive, giving me 7 over 4. I need to isolate y. Actually, we're asked to express the equation in standard form. So I do want to get my terms, join my like terms. So I've got a constant 4 over here and a 7 over 4 on the right. So I'll subtract subtract 4 from both sides. And I'm going to do in one step. If I subtract 4, I realize that I'm going to need to get a common denominator of 4. So that's 4 is the same as 16 over 4. You could do that in 2 steps if you want. But when I subtract 4, I recognize that I'm going to ultimately be trying to join these like terms. They're both constant values, so I'm going to need to have a common denominator of 4. So I've changed the value of 4 over 1 to 16 over 4. So this becomes minus 1 quarter x. 7 subtract 16 is minus 9 over 4. All right, so I'm asked to do it in standard form. So I know standard form cannot have any fractions, so I'm going to multiply everything through by 4, giving me 4y is equal to negative x subtract 9. 4 times y, my 4's divide out when I multiply by negative 1 over 4x, and the 4's divide out when I multiply by the negative 9. I add x to both sides, giving me x plus 4y. I bring the 9 across, it's negative 9, so I add 9 to both sides, giving me x plus 4y plus 9 equals 0. And that is the equation in standard form. So we'll have a concluding statement. Therefore, the equation of the line that is parallel to x plus 4y minus 2 equals 0 and passes through the point 7 minus 4 is x plus 4y plus 9 equals 0. Okay, so we can see the questions become more complicated, right? We're starting to have multi-step processes to solve these problems, and this is where it's important that we solidify our understanding at every stage after each lesson. Take a look at the next page, parallel and perpendicular lines. Determine the equation of a line that has the same x-intercept, that's a point, as 2x minus 3y minus 6 equals 0, and is perpendicular to the line 8x minus 4y plus 1 equals 0. Express the equation in standard form. All right, so right, so we know that in order to come up with the equation of a line, I need a slope, I need a point, and then that will allow me to generate an equation. So do I have a slope? Well, if it's perpendicular, as soon as I see that word, alarm bells go off to think about slope. So it's perpendicular to this line. So if I can find the slope of that line, line 2, then I know that the slope I need is going to be perpendicular to that. So it's going to be the negative reciprocal of that slope. So I get, from my line 2, I get 8x minus 4y plus 1 equals 0. And this is from line 2. Rearrange my equation. I get negative 4y, subtract x from both sides, subtract 1 from both sides, and then divide both sides by negative 4. Negative 8 divided by negative 4 is 2. Negative 1 divided by negative 4 is positive 1/4. So this tells me that the slope of line 2 is 2 over 1. Therefore, the slope of my third line, this is the equation here, is going to be the negative reciprocal, so it's going to be negative 1 over 2. The point I'm given, it has the same x-intercept as this line, as line 1. So line 1, I've got the x-intercept. With the x-intercept, that crosses the x-axis when y is equal to 0. So I can take my line 1 and say that becomes 2x minus 3 times 0 minus 6 equals 0. Right? Normally, I wouldn't actually bother writing out the 3 times 0 because I know that when I substitute in 0, that term will just disappear. But it's just to, to highlight that becomes 2x minus 6 equals 0. Add 6 to both sides. X equals 3. So my point, therefore, point of interest is x3, y0, because y was 0. So it's crossing the x-axis at 3, 0. So I know that my line has the same x-intercept. It's going to pass through 0.30. So that means I now know that my point is 3, 0, and the slope of my line of interest is -1/2. So, right, my slope is -1/2, and my point is going to be 3, 0. I've got my slope, I've got my point. I now use the slope point form of my equation and substitute in my x, y's, and my slope. Y minus y1 is 0, is equal to slope -1/2 times x minus x, which is 3. Or y becomes -1/2 x, -1/2 times -3 is +3/2. So I think I might be done, but I need to read the question again. Express the equation in standard form. So I need to get rid of my fractions. I multiply everything through by 2 to get rid of my fractions. It becomes 2y minus x plus 3. Add x to both sides. X plus 2y. Subtract the 3 from both sides. Becomes 0. So this becomes the equation in standard form that is parallel to line 1, or sorry, that is perpendicular to line 2, perpendicular to this line, and passes through the same x-intercept as line 1. So we will finish with a concluding statement. Therefore, the equation of the line is x plus 2y minus 3 equals 0. Okay, I'm going to pause there and I'll make a second video for the last page.